Hello and welcome. My name is Jesse Cook. This is for class ISA4220 System Security 2. Today we will be giving a presentation on IMAP and DNS hardening. First we will go into a technical description of each, and then we will proceed by giving hardening recommendations for each service. The first protocol we will be talking about today is IMAP. IMAP stands for Internet Message Access Protocol. This protocol uses an unencrypted port of 143 and it uses an encrypted port of 993. The IMAP protocol is a little different than any other protocol in that the messages that you receive are actually stored on a mail server. Whenever you check your inbox, your email client contacts the server to connect you with your messages. When you read your messages using IMAP, you aren't actually downloading or storing them on your computer. Instead, you are actually reading them off of a server. So essentially, this protocol lets you view and manipulate messages as if they were stored locally, but instead you're actually fetching and reading and manipulating them from a server. IMAP is the most similar protocol to POP3. It is actually its successor, which we will talk a little bit more later on in this presentation. Some of the features that make IMAP unique is that it supports simultaneous logins, and this is because all your messages are actually stored on a server, so you can live view your email messages from multiple devices at the same time. It also gives you more administrator capabilities and enables client and mobile pull downs. This essentially means that if you pull down on one device, such as your mobile phone, and you pull those emails, it will not directly download to the device. Your emails will be on the server, like we said before, and you can actually access those from multiple devices. Now that we've done an overview of the technical breakdown of IMAP, we're just going to do a little comparison and see the differences between IMAP and POP3, the protocol that we viewed last week. IMAP is actually POP3's successor, so it is the protocol that came out to actually replace POP3. The main differences between the two are how the messages are delivered to the user client. In IMAP, the messages are stored on a server and they can be viewed and manipulated as you would like. And with POP3, the messages from the server are pushed to the user on the device that they are on, and once they are pushed from the server to the user's device, the messages are deleted from the server. This makes IMAP much more versatile and user-friendly for multiple devices. IMAP has also revolutionized how messages are delivered to the user. IMAP messages are actually downloaded individually, not pulled as a group. So as messages come in, you can view them even while other messages are being downloaded. This is because they download individually. IMAP attachments are also not downloaded automatically, unlike other protocols. This helps save room on the server and on the user device whenever it is accessed. This also makes IMAP one of the fastest protocols that you can use on your server. Now that we've looked at what IMAP is and how it differs from its predecessor, POP3, we can look at some hardening recommendations that we could make for installing it on a server. For our Ubuntu server in this example, we're going to use the Dovecot service to set up our IMAP server. When hardening, we always want to use TCP/IP port 993 for IMAPS. This is a secured, encrypted port instead of the other port that IMAPS uses, port 143. The next recommendation that we can make would be to enable encrypted login. Some email clients do not have this enabled by default. It will send your logins through text, and these can be deciphered by hackers or attackers. Another hardening recommendation would be to keep whatever email client you are using updated. In this case, we are using Dovecot, so we would need to keep Dovecot updated on our server. The next recommendation would be to enable SSL. SSL stands for Secure Sockets Layer, and this is a standard security protocol for establishing encrypted connections between a web server and a browser. So this will keep all messages encrypted upon transfer. When SSL is enabled, there will be a private key made in the process. You must protect this key at all costs because this is the key to solve the encryption upon the other side. If an attacker or hacker gains this key, they can crack all files that has been used to be encrypted with. Now that we have discussed the IMAP protocol in detail, and we have given some hardening recommendations for our servers, we will move on to our next protocol. Our next protocol is DNS, which stands for Domain Name Servers. DNS is essentially the internet equivalent of a phone book. It is a large collection of directories of domain names and IP addresses. Essentially, what this means is when you are using a web browser and you put in a URL, that is a domain name that is sent off to a set of servers. The server then takes the domain name and connects it with a record that matches the same description in its directory. It then translates this domain into an IP address and gives that to your device. Another feature that DNS has recently enabled is recursive queries. This means that if your domain is not found on the first domain server that it enacts, then it will move on to the next one until it finds a solution for your URL, or it times out. DNS servers are not just domain names though. They also store a directory of crucial information regarding domain names. Examples of this are email server records, sending verifications, text record verifications of domain ownership, and even SSH fingerprints. They can all be supplied upon the correct request. Now that we know a little bit more about DNS, let's talk about some hardening recommendations that we can make for both of our servers. The services that we will use to manage our DNSs are, on Windows, we will use IIS, and on Ubuntu, we will use a program called Bind. All DNS requests use port 53 TCP/IP port. And the first recommendation that we can make would be to utilize the internal and external DNS. Using this split DNS route will allow you to use both an external DNS for your regular public queries And the internal DNS will also provide the public DNS queries and additional information about internal hosts and services. This will also bring the company's risk down because the DNS server is split into two separate areas that are both hardened. The next hardening recommendation that we can make is to restrict zone transfers. You can restrict these zone transfers by enabling access control lists on the server. This will prevent the server from being used for recursive queries. Another hardening recommendation we can make is to use DNS SEC when it is applicable. DNS SEC stands for DNS Security Extensions, and they are when a DNS server digitally signs your DNS data so that name servers that receive it can ensure its integrity prior to providing it answers to queries. This will make your DNS searching much more safe. The last hardening recommendation we can make is to block your cache from poisoning. Poisoning occurs whenever attackers manage to insert false address records into DNS servers. So when victims mistype DNS addresses, it will give them an IP address to their malicious website. And that reaches the end of my presentation. Thank you for your time. Here are the sources where I found all this information and cited. Thank you for your time.